In order to see better the effect of normalization, you can display four images at the same time on one screen. The original structural, the original functional, the normalized structural, and normalized functional. Let's see how to do it practically. We start ChatGPT. We go to structural and we select the original and the normalized. Then we go to functional and we select the original and with the help of the filter W, the normalized. 4 files must be selected, and then you click done, and this is what you get. It looks pretty nice. Those two correspond to each other because they are original. But they differ pretty much from the normalized. You see here the extent of the brain in the vertical direction is smaller for the original than for normalized. And here, on the contrary, there are also pretty significant differences in the shape of the ventriculi. Here they are much larger than here. And located differently. Okay. Now we can stop this and to go to the next step, which is the final step of preprocessing, and is called smoothing. You smooth just the functional images. You have to indicate the degree to which you are going to smooth, which is 6 millimeters. Gaussian kernel, and you indicate the file name prefix as S6 so that you remember that you smoothed to 6 millimeters, and you save the job. I will show how to do it. You click smooth. For images to smooth, you select normalized functional images, 84 files, smoothing parameters 666, isotropic, and the prefix is S6. And now you save it to jobs as smoothing. And now you run it. It does have to take a lot of time, but let me tell you a few words about why do we need to run smoothing. In fact, you can do your statistical analysis, and I hope you are going to try it without smoothing. But normally smoothing is useful for a few reasons. First, with smoothed functional data, you have less noise. Each individual voxel is much noisier than the average of a pool of voxels. But the average of pool of voxels, if the size of activated cortical area is big enough, will still be sensitive to this activation. Less noise, same signal. Better signal to noise ratio. And the other reason is that you try to decrease the inter-subject variability. For the analysis at the level of a single subject, it is irrelevant, but at the end of the day, you normally want to estimate the group statistics for the group of your experimental subjects. And even though you normalize each individual image towards the canonical template, you still have both the tiny structural differences between the subjects and also you have functional differences. The same structure in the brain, depending on the individual, can respond with activation to different tasks, different experimental conditions. And the same experimental condition quite possibly is going to activate slightly different areas of the brain in different subjects. When we apply smoothing, we make the task of the estimation, the average group activation, more feasible. And since the smoothing is completed, you can again run the check-reg function in order to check the difference between the unsmoothed and smoothed image. For unsmoothed, you enter filter W with caret at the beginning, like this.
Володя, не бачимо.
Не бачимо.
Або трошки відходьте, щоб ви бачили, що у вас там назви на презентації.
This is the filter you enter in order to get listed only the files starting from W. And you select the first one. And then you enter different filter, S6. And you see all the files listed starting from S6. And you also pick the first one. Now you have two files, unsmoothed and smoothed. And you click Done. And you can see the difference between the unsmoothed and smoothed functional image. The smoothed image looks more smooth. With less resolution, obviously, but also at the same time, hopefully, less noise. If you have time and desire, after our training session, you can run the statistical analysis separately for the unsmoothed images, and you can compare the statistical results if they are any different in the unsmoothed data or not. I think they will be pretty different, with a lot of so-called false positives in the shape of single voxels which look activated but in fact are just artifacts, and they will be scattered all around the image and even outside the image. But this is something to be tested afterwards. At the moment, we can say that the pre-processing, spatial pre-processing, is finished, and we can start the next important part of our class today, the statistical analysis. This is the ultimate goal of all the pre-processing, to get the idea where the brain, which part of the brain responds to the task and which part of the brain doesn't. The statistical analysis includes several steps, and this is the portion of the menu window you will use now. First, you go to model specification. This is a very important step where you have to indicate what do you expect from your data. When in time do you expect the activation to occur? Then you can review your design to see if it is okay according to several important criteria I will tell you later. Then you estimate the model, which is very easy. You just click estimate and it runs everything automatically. And at the very end, you have to explore your results. And there you will have a lot of options of how to see your results, how to check if the results are significant or not, and how to make some beautiful figures to show in your papers and presentations. But let's start from the model specification, the most important and critical part of this statistical analysis. You click specify the first level. You open timing parameters, and for units of design you select scans. You can select seconds instead of scan. It is absolutely equivalent, but then the onsets and durations of your conditions must be indicated also in seconds. At the moment, let's indicate scans. But if you indicate scans, don't forget to mention that the interscan interval is 7 seconds. It is very important, so that the program understands well what is your design. For data and design, you create new subject and you select the functional scans, smoothed, normalized functional images, from this one to this one, in total 84. You can use this filter and select all. Then you create conditions. There will be just one condition. You name this condition listening, You indicate the onsets and the durations. What does it mean? This is again a piece of MATLAB syntaxes. Starting from 8 with the step of 12 till 84, it will generate an array of values. For example, the first one is going to be 6, the second one will be 18, the third one is going to be 24, and so on. If you enter this in MATLAB, you will get precisely the array of the onsets that is going to be used. What does it mean? This means that the first onset of the stimulation is at the 6th scan, the second at 18th scan, the third at 30th scan.
Володя, не встигаю.
You just copy and paste in MATLAB and this will give you a good idea of how MATLAB works with data arrays. This is the good way to indicate the onsets, since our step is always the same: 6 scans rest, 6 scans activation, rest, activation, rest, activation. But let's go back to the presentation. So for conditions, you select one condition, you create one condition, you call it listening, you indicate onsets, you indicate durations of each condition. For example, this condition happens every 12 scans, and it lasts 6 scans, which is 6 times 7, 42 seconds. And you indicate the directory. They propose to call it classical. Let's call it classical, but actually this name of the directory can be chosen absolutely arbitrary. It is just important that you understand why do you call this directory this way. This directory will include all the results of the statistical analysis, of the given statistical analysis. If later you want to run a different statistical analysis with different settings, parameters, conditions, you just have to create a new directory and indicate it here. Now I will go to SPM and do everything necessary according to the proposed design. The directory is classical. we created in our main directory, and we indicate this directory here, classical. Timing parameters, the units of design, scans, interscan interval 7 in seconds. By the way, you can always read the help which is provided at the bottom of this editor. This help is quite helpful since it explains in simple words what is the importance of any given option. Then you go to data and design, you create new subject or session. For scans you indicate the smoothed functional scans. You select all of them, 84 files, load, and conditions, you create new condition. There will be just one condition, we call it listening. The onsets, you can just copy paste. Okay, now you see that all the onsets are properly estimated, and durations is 6. And that's all. Just don't forget to save the batch, and we call it model specification.